Lesson 8 is solving rational equations, the second part. Really all we're doing is looking at rational equations where the denominators might be a little bit more complex. So when we go through the solutions, if you have a single term on each side, cross multiply. When you cross multiply, you eliminate the denominators. That's what you're trying to do when solving rational equations, is you want to multiply by something that's going to get rid of all of your denominators. If you have more than one term on either of the sides, that's when you would use what we would call the lowest common multiple of the denominators. Or I call it just say lowest common denominator. And then from there, you'll end up either getting a linear or a quadratic equation, which you can solve using all of the methods that we've used for the past 2 years. Always make sure that you check and are aware of your domain restrictions when dealing with your rational functions. Because an answer for a linear equation or for a quadratic equation may not actually work in the original rational function. It's like when we were doing the radical equations, sometimes the answer worked for the simplified, but did not work for the radical equation itself. So if we look at class example number 1, in the previous lesson we had the equation 3 over x plus 1 plus 1 over x minus 1 equals 2, and we solved it graphically. And when we solved it graphically, we got solutions of 0 and 2. So now we're going to look at solving this equation algebraically. So to solve this algebraically, I need to multiply by a common denominator. What would that common denominator be? So that's what I would multiply each of the 3 terms by. So when I go to multiply 3 over x plus 1 by this common denominator, the x plus 1s would cancel each other out, and I'd be left with a 3 times x minus 1. When I multiply the second term by my common multiple, what cancels out is the x minus 1s, and I'm left with an x plus 1. And then nothing cancels for the term that's on the right-hand side. So it would end up being 2 times x plus 1 times x minus 1. At this point, I would then multiply to remove all of my brackets. So 3x minus 3 plus x plus 1. When I go to multiply x minus 1 times x plus 1, what do I have? And what do I get when I multiply that difference of squares out? X squared minus 1, which when I multiply by 2, I would get 2x squared minus 2. At this point, unlike the questions that we did yesterday where our x squareds tended to cancel out on both sides, that's not going to happen, which means I'm going to end up with a quadratic equation. So we're going to move everything over to the other side. Before we do that, let's just simplify this side. So how many x's would I have? So 4x minus 2 equals 2x squared minus 2. If I move the 4x over, it will become negative. If I move the negative 2 over, it will become positive, which means it'll cancel out this negative 2. So now I'm at this step. This is not a trinomial, so we're not factoring it by trinomial needs. It has 2 terms. So the first thing I always start off with, can I remove a greatest common factor? Which leaves me with x minus 2. These become my 2 factors for my solution. If either one of those factors equals 0, the equation would equal 0. So I'd have 0 equals 2x, and 0 equals x minus 2. So if 0 equals 2x, I get that x equals 0. And when x minus 2 equals 0, I have that x would equal 2. And now I have my two solutions. What are my non-permissible values? What can't x equal? Positive and negative 1. Okay, so let's look at the next question. Consider the rational equation x squared minus 5x minus 6 over x plus 1 equals 2. What can't x equal? Negative 1. Okay. If we solve the rational equation through cross multiplication, I can write that as 2 over 1. So I multiply x squared minus 5x minus 1 by 1, which means it won't change. And then I multiply 2 by x plus 1. And what do I get when I multiply 2 by x plus 1? Again, I can't cancel out this x squared, so I should move everything over onto one side of the equation. If at all possible, keep your x squared the positive term. So if I bring the 2 over, I would get negative 7x. Bring the 2 over, I get negative 8. How do we solve quadratic equations? Factor it. So we check to see if we can factor it. If we can't factor it, then we would try to use the quadratic formula. So can you give me two numbers that multiply to negative 8 and add to negative 7? Negative 8 and 1. So I get x minus 8 and x plus 1 equals 0. So if either one of these two factors equaled 0, the whole thing would equal 0. That's my 0 property. So if x minus 8 equals 0, what does x equal? 8. And if x plus 1 equals 0, x would equal? So this ends up being rejected because x can't equal negative 1 in my original equation. So then my solution becomes x equals 8. So question B just says, explain why one of the solutions to the quadratic does not satisfy the original equation. And that's if x equals negative 1, then the denominator, x plus 1, would equal 0. And I can't divide by 0. That's why you have the rejection. I cannot divide by 0. So in class example number 3, we're asked to state the non-permissible values, solve, and verify. So in A, what's my non-permissible value? What can't x equal? 0. Okay. What would be my common multiple? What would I multiply each term by to get rid of that denominator? X. So I'd multiply each term by x. So x times x would be x squared. The x on the top and the bottom would cancel, which would leave me with 2. And then that would equal 3x. Then what should I do?
Move the 3x to the other side.
Okay. So now I have a quadratic. Can I factor this quadratic? Can I determine two numbers that multiply to a positive 2 and add to the negative 3? So what are my possible solutions for x? What can x equal? 1 and 2. So x can equal 2, x can equal 1. Now I need to verify. So if x equals 2, I'd have 2 plus 2 over 2 is supposed to equal 3. What's 2 over 2? And what's 2 plus 1?
3.
That verifies. Then I do the same thing for 1. I have 1 plus 2 over 1. What's 2 over 1? And what's 1 plus 2? So that verifies. Okay, so let's take a look at B. First of all, what's my non-permissible, or before I get into my non-permissible values, is there anything that I should start off with?
Factor the x squared minus 4.
So factor what is a difference of squares. So that helps me, first of all, with my non-permissible values.
Excuse the interruption. Could all elementary classes please head to the gym for the off-ramp presentation?
So what are my non-permissible values? So x cannot equal positive and negative 2. Okay. This time, I know that instructions at the beginning said if there's one term on each side, cross multiply. Would you want to cross multiply in this case? What would be my common multiple? What would I multiply each term by in order to get a common denominator? X plus 2 and x minus 2. So take a look at that and explain to me why you'd want to multiply by this common multiple rather than cross multiplying. So what do I get if I cross multiply? I would get x squared plus 2x for multiplying these two. And then I would get 2x squared minus 8. If I multiply by this common denominator, or common multiple, this is going to cancel out. So what will I be left with here? X. And what will I be left with on the other side? 2 times x minus 2, which would give me x equals 2x minus 4. This is going to bring me to a quadratic that I'm then going to have to factor, and I'm going to have a whole bunch more steps. What can I do here? Put the x on this side. And what do I get when I put the x on this side? So I get x minus 4 equals 0. What does x equal? So just to show you, if we had done the cross multiplying and continued it through, so x squared plus 2x equals 2x squared minus 8. So I'd bring this x squared to the other side. And I get x squared minus 2x minus 8. So two numbers that multiply to negative 8 and add to negative 2 would be negative 4 and positive 2. So I get an x equals 4 and an x equals negative 2. I have to reject that one. I would still end up with the x minus 4. I just have a couple more steps. And then my last thing would be to verify the solution that I did get into that equation. So I get 4 over 4 squared minus 4. What's 4 squared?
6.
And 16 minus 4?
12.
So I get 4 over 12, which reduces down to what?
1/3.
1/3. So that's my left side. If I was to simplify the right side, I would get 2 over 4 plus 2, which would be 2 over
6.
which reduces down to 1/3. So there's two ways that I can show my verification. I can use a column with a line down the middle, simplify the left side to the right side, or I can do them horizontally. Depends on the amount of room. Sometimes when it's fractions, it's easier to move across horizontally than trying to do steps down. And then you just have your left side and then your right side underneath. Okay, one more question. Show that the following equation has no solution. So what can't x equal in this question? That's what we start off with.
3.
X cannot equal 3. I have more than one term on one side, so I can't use the cross multiplying. So what would I multiply each term by to get rid of the denominators? X minus 3. So when I multiply the first term by x minus 3, it cancels the denominator out, leaving me with an 8x plus 10. And then I take that negative 4, and I have to multiply it by the x minus 3. And then the x minus 3 over the x minus 3 again would cancel, and I'd be left with 10x plus 4. What would I do next?
Expand out the 4x minus 3.
Okay, and when I expand that out, what do I get?
Negative 4x plus 1.
Okay, now what? What's that? Okay, and when I collect the like terms, what do I get?
4x
Okay. Now what?
I would move the 4x plus 22.
Would you move both terms over to the other side?
No, just the 4x.
Okay, so if I move the 4x over, what would I get?
6x.
Okay. Now what?
Move the 4 over.
Okay, and when I move the 4 over, what do I get instead of 22?
18.
So then what does x equal?
3. It can't equal 3.
Why can't it equal 3?
That was our permissible value.
Since x can't equal 3, there is no solution. 3 works for this equation right here. If I put 3 into this equation, I'd get 34 on this side. And then I get 24 minus 0, so I'd get 24 on the other side. So, or 34, sorry. Yeah, 24, 34 minus 0. I get 34 on each side. It works here. But in the original equation, which is where I have to go up to, I get a 0. Can't divide by 0. This is a rejected answer. And because it's a rejected answer and there is no other answer to fall back on, there is no solution. Graphically, what this looks like is it's a graph that doesn't have an x-intercept. So it still forms a graph. I can still make a table of values. But what it means is it does not cross the x-axis. Okay, your questions. Okay, so 1A, 2B, 3A,